A lot of these proofs are just like those proving triangle congruent proofs. That's literally all we're doing. Okay. So we look at the first one. It says, prove that in a parallelogram the opposite sides are congruent. Okay, and one big thing with these parallelogram proofs, you can't use other theorems about parallelograms until you prove them. So you might be thinking, well, yeah, I already know the opposite sides of a parallelogram are congruent. So you have to go through and actually complete the full proof and act like you don't know that. That's what you're trying to show. And you'll see on your practice and on quizzes on tests, it will tell you you cannot use other parallelogram proofs or parallelogram theorems on this one. Okay. So all we know is that we have a parallelogram. Did they give us a diagram of that parallelogram? No. So what do you think would be really helpful for us to do? Yeah, draw. Cheat and draw a parallelogram or reminding me. Okay. Well, bear with me on my drawing with parallelogram. Here. There we go. There's my parallelogram. And label the vertices A, B, C, D. In that order. A, B, C, D. Okay. So, what's our first statement and reason every single time? Given. And all we were given was this parallelogram that we had to draw. We were given, you can abbreviate parallelogram with this symbol of a mini parallelogram. Parallelogram A, B, C, D. That way you don't have to write out the whole word. You might see me abbreviate parallelogram. I just use the parallelogram symbol, the parallel line symbol. You might see me write it as that as well. Yep. Okay. Well, start thinking about things that we know about parallelogram just based off the definition. We can't use any other properties or theorems. By definition, what do we know about a parallelogram? It's two sets of parallel sides. Good. The opposite sides are parallel. Okay? So that's your first step. Is to state that the sides are parallel. So AB is parallel to what side? CD, the opposite side. So I know this side is parallel to that side. And then BC would be parallel to what other side? We knew that by just knowing the definition of a parallelogram, so guess what your reason is going to be? Definition of a parallelogram. That's what I like to write. Parallel. Okay. Or you need to listen. Okay? And you can also think of it in our given information, we had a vocab word, parallelogram. So we know our next reason is going to be definition of a parallelogram. Definition of that vocab word. Okay? And we said essentially with these parallel line proofs, okay, we're trying to show that two triangles are congruent. Do we have two triangles right now? No. But we can draw in a diagonal to make it so that we do have two triangles. Okay? And it doesn't matter which diagonal you pick. I just picked AC. You could have picked BB. Does not matter. But you have to state that you drew that in your proof. So all you're going to state for number 3, in order to get your two triangles, you're just going to write draw AC. Okay? So whatever line you drew, that's what you're going to say is your reason. Your statement. And your reason for that is 2 points make a line. Make sure I have that correct. 2 points make a line. So if you don't have the diagonals given to you in the diagram, or if you're not told in your proof that you don't have the diagonals, you have to draw in it. Okay? And when you do that, you just say draw, and then whatever diagonal you made, and your reason is 2 points make a line. You can connect any 2 points with a line. Okay? Now that we have two triangles, We're just doing those triangle proofs, okay? We have to prove that those two triangles are congruent. Because if we prove that these two triangles are congruent, then we can say that the parts are congruent. And their parts are A, B, and CD. We can state that those are congruent. And we can say that AB is congruent to BC. And that's what we're essentially trying to prove. Okay? So think about what we said earlier on in our proof. We said that lines were parallel. And when we do these triangle proofs and we have parallel lines, what did we say our reason is like 99% of the time? Good. Alternate interior angles are congruent. When we have these triangle proofs, even with these parallel line proofs, when you have parallel lines, we know one of our reasons is going to be alternate interior angles are congruent. We just have to state as our statement what those alternate interior angles are. What's one angle? Careful. Here's our parallel lines. Here's one set of parallel lines. Here's our transversals. Angle BCA. Good. Good. We have angle BCA, and I also like to think to help you get alternate interior angles. If you make a Z, notice how we made a Z. The corners of that Z are going to be your alternate interior angles. So we can say angle BCA is congruent to C or DAC. We have to go in order. Do it. BCA, we have to do DAC. Okay, that's dealing with the top two parallel lines. Now we can say alternate interior angles for the two side ones. Okay? And guess what? The alternate interior angles for the other two are just going to be the angles right next to it. Okay? So the other set of alternate interior angles are just going to be this one and this one. Okay? They're just the two little angles next to the first set that you've stated. Okay? So we can state that those angles are congruent. So we can state that angle DCA, and this is where it gets confusing because you're using a lot of the same letters, but you're naming completely different angles. DCA is congruent to what? AC. Okay? So we're going to do that purple. Are you ready? A is congruent to angle. Okay, because alternate interior angles are congruent. Well, we have two parts marked, we have two angles marked, and we reverse back to that unit where we did these triangle proofs. What kind of triangles are these? Shared side. Very good. And what did we say our reason was with shared side triangles? Reflexive. So we know because we have shared side triangles, we know we're going to use the reason reflexive property. And you just state that that shared side is congruent to itself, but because the triangles are flipped, you have to flip the letters. So AC is congruent to CA. And I'm going to mark it. How can we now say we have three pieces marked? How can we say that these triangles are congruent? Okay? Perfect. So now we can state for number 6, we can now state that triangle, and again, a little trick, just steal one of your angles and just use a triangle symbol. So I'm going to steal this right here. I'm just going to say triangle BCA is congruent to triangle DAC. To steal an angle, put a triangle symbol. And just as she said, it's angle side angle. Okay, because we look angle, then a side, then an angle. Angle, sides, and angles. Now that we just showed that those triangles are congruent, we can state that their parts are congruent. Okay? And our parts are what we're trying to prove. Those triangles are congruent, so we know the opposite sides are congruent. So I know this side is congruent to this side. We also know that this side is congruent to that side. What reason do we always use to say the parts of triangles are congruent? CPCTC. Okay. So then we would state what we're trying to prove. AB is congruent to CD and BC is congruent to BA. And BC is congruent to DA. And our reason is CPCT. So whenever you have a parallelogram proof, you're dealing with parallelograms, and you're trying to prove a theorem that like opposite sides are congruent or opposite angles are congruent, things like that, all you're doing is a triangle proof. You're showing that making triangles if needed, showing they're congruent, and then saying their parts are congruent. It's really no different than what you've done in the past. You just have this extra step of where you have to state the lines are parallel because it's a parallelogram. Okay. Questions? Take a look at another one. So number 2 says, prove that in a parallelogram the diagonals bisect each other. Okay, so we're trying to prove that. And again, we can't really use any other parallelogram proofs. Okay? There's one we can use, I believe, because we just proved it. But again, you're like, I know that's a theorem, why can't I just state it? Because we're trying to prove it. Okay, so you can't use what you're trying to prove in your proof. Yes? No. Yeah, it will say you can use other proof theorems, and it'll say you can't. If it says you're allowed to, that usually means you kind of have to use one in order to prove it. But if you don't have to use one in order to prove it, then you don't. As long as your work is correct and you did the right steps, no, you won't lose points. But sometimes there's different ways or a different order and things like that. So again, just like any other proof, our first statement and reason is a given. So we have parallelogram A, B, C, D with E as the intersection of diagonals. I'm going to abbreviate diagonals. That's given. We weren't given the diagram, but we're going to draw one based off the info. And it said it had diagonals. So because of the given information, it said it had diagonals. We don't worry about having to say that in our proof. Okay? We don't have to do this step where we had to say, oh, I'm drawing in a diagonal. You only do that if it doesn't mention diagonals, or the diagonals weren't in the diagram if it did give you one. But it mentioned the diagonals, so we don't have to worry about drawing them in our proof. We can just draw them right now. So we have A, B, C, D. We know we have diagonals. So I'm connecting, and to make your diagonals again, you're just connecting the opposite corners. And it said E is where they intersect. That's their intersection point. So, right off the bat, we're given a parallelogram. What do we know about parallelograms? Their opposite sides are parallel. So that's what you want to do right away. 2. State the opposite sides are parallel. We're going to say AB is parallel to BC. And BC is parallel to DA right away. I have a parallelogram, I'm saying their opposite sides are parallel. And I know I'm going to be using that in my proof. And your reason every single time when you write that, what's our reason going to be? Definition of a parallelogram. Okay. And that's telling me, I might not use it right now, but that's telling me I have parallel lines. What's going to be my reason in my proof at some point? Alternate interior angles. Okay, we're going to use that a ton. And again, with these proofs, essentially what we're doing is just proving that triangles are congruent. And then stating that their parts are congruent. Okay, and this might get, I think there's one that's like super messy. That's not that. Okay. So, and it doesn't really matter which triangles you pick to prove congruent. What did I pick? I picked, okay, so essentially we can prove that these triangles, this triangle, and this triangle are congruent. We can state that their parts are congruent, which show that the diagonals bisect each other. Okay? You could have picked the bottom two. Okay? It doesn't matter. I just picked those two. Okay? We're not showing that the big triangles are congruent like we did on the last one, because that's not showing the diagonals bisect each other. Okay? You have to pick the two little ones. So whenever it's talking about the diagonals bisecting each other, you're picking either these two little ones or these two little ones. Okay? So we have parallel lines. We just said it a little earlier. Parallel lines, I know my reason is going to be alternate interior angles. Every time. I just like take care of that right away. And then figure out what else I need to do to get those triangles to be congruent. So we want to make sure we pick alternate interior angles that are inside those triangles. Okay? We picked those, the yellow one and the blue one. You could have picked the other two. Doesn't matter. So pick one of the alternate interior angles that's inside that triangle. I'm going to pick this angle. Angle AB. And it's super important. You have to say angle ABE. Okay? ABE. Because that's part of the triangle. If you say ABD, is D in that yellow triangle? No. Okay? So you have to say ABE to make sure you're stating the angle inside the triangle, not just a random angle. Okay? It's congruent to, what's the alternate interior angle to ABE? CDE. Good. Make sure you have that E because we want to include the triangle. If you went to B, that wouldn't be right. We still have another set of alternate interior angles. Yes. Good. BAE, that angle down there, is congruent to what other angle? Good. UCE. Those are alternate interior angles. So now we have two parts in those triangles. We need a third. Yes. It's really tempting, and you're right, there are vertical angles. But is angle a shortcut when proving these triangles congruent? We can't use angle. Because you can have a big triangle that has three angles that are the same, and you can have a little triangle that has three angles that are the same. So we can't use it as a shortcut. But think about, yes? What did you say? We would go, that might work, but there's one easier. Because we proved it in the last proof, we proved that the opposite sides are congruent, we can use it. Okay? Yes. It will tell you that you can use it. Okay? So because we proved it, we can use it now. So then what do we know? What opposite sides would help us say that these triangles are congruent? Libby? Good. So we can state that BA and DC are congruent. We proved it, now we can use it. So we're going to say BA is congruent to DC. And again, it will say you can't use other parallelogram theorems in this proof. That means you don't need other ones to prove it. If it says you can use other parallelogram proofs, that means you'll probably be using other ones, right, to help you out. Right? So, and then what would our reason be? Is just stating that theorem. Opposite sides of a parallelogram are congruent. Just state that theorem. Opposite sides parallelogram are congruent. Let's state what that theorem is. Okay. Now we have three parts. How are these triangles congruent? What reason can we put? What's our reason for stating that these triangles? Angle, side, angle. Angle, side, angle. Angle, side, angle. So we're going to say, again, you can just steal one of these angles up here. Just put a triangle symbol. ABE is congruent to triangle CBE by angle, side, angle. And then now that we said that the triangles are congruent, our very last step can be that the parts are congruent. And that's the parts we're trying to prove. That piece right there. AE is congruent to CE and BE is congruent to DE. Here are the diagonals. We just showed that they bisect each other by proving that those triangles are congruent. And that means their parts are congruent. So we would just state what we're trying to prove. And again, what would our reason for that be? Okay? Questions over that? Again, you're literally just doing those triangle proofs. Okay? That's all we're doing. You're just using the fact that you have a parallelogram. So you have to remember to state, oh, opposite sides are parallel, and then at some point you're going to be using alternate interior angles. Okay. Questions? Okay. Now what we're going to be doing is we're going to be given a converse of what we just proved. We're going to be told that the diagonals of a quadrilateral bisect each other. Okay. And then we have to prove it's a parallelogram. We're going backwards. Okay? So the steps are really, really, really similar, but slightly different. So you know the first step, make your two columns. Statements. Reasons. Okay. Okay, so we know the diagonals of our quadrilateral ABCD bisect each other. That's what we're given. That's our given. And again, draw that diagram out. Okay. A, B, C, D. Following the diagonals. And we know that they bisect each other. Okay. And again, we don't have to state draw in our diagrams like we did on the first proof because it told us we had diagonals in the given information. Okay. Well, let's take a look at our given information. Okay, we were told that the diagonals of ABCD bisect each other. So we have to state that as our reason. If they bisect each other, what do we know about? And we're going to say they intersect at E. It didn't say it. But we're just going to draw on a point E. So what do we know about BE and DE? They're congruent. What other parts do we know that are congruent? Good. AE is congruent to CE. What would a reason be for that? Right? Then other than track, think about what the vocab word is. Bisect. Good. Definition of a bisector. Specifically, definition of a segment bisector. Good. Vocab word bisects. So we know we're going to be using definition of a bisector, specifically a segment bisector. And you're just stating the segments that are congruent. Okay? So I'm going to mark that. Yeah, when that happens, just put a point. Doesn't matter what point you put. It was given to us on the last one. I just forgot to give it to you on this one. Okay? And we're kind of working backwards on this one. We can't use the fact that we have parallel lines because we don't know if this is a parallelogram. We're trying to prove that it's a parallelogram. But the steps are still the same. Okay? We're still trying to show that those two triangles are congruent. We're just trying to show that they're congruent in a different way. Okay? If we can show that those triangles are congruent, we can say their parts are congruent, and then use that to help us show we have a parallelogram. Okay? Well, we have, again, we're using the same triangles as the last one. This one and this one. Okay? We had two parts. What would be our third part? How can we show that that third part's congruent? Yeah, vertical angles. Very good. We have vertical angles. This is where they come into play. And we know vertical angles are congruent. These angles right here, they're vertical. That gives us our third part. Okay? So we just have to say that angle BEA is congruent to angle DEC. No, that's fine. Nope, that's still correct. Okay? So now can we state that these triangles are congruent? Yeah, what reason allows us to say that these triangles are congruent? On both sides. So we're going to say that triangle, again I'm going to steal these angles, BEA. BEA is congruent to triangle DEC by side angle side. If we know the triangles are congruent, then we know their parts are congruent. And the parts we want to show are congruent are the angles. Because we are going to reverse of what we did on the last proof. Okay? Because if we can show that in this quadrilateral, that alternate interior angles are congruent, then we know we have parallel lines. Okay? So I'm going to state that purple, this angle and this angle are the same. By what? If we show the triangles are congruent, what's our reason behind it? CP, CTC, their parts are congruent. So we're going to state that angle ABE, because again it has to be inside that triangle, is congruent to angle okay, good. CDE by CP, CTC. Okay. And we're going to say that the other two angles are congruent. So I'm going to say BAE is congruent to DCE. by CP, CTC. So I'm going to write them in the same line. Wait, I said BA is congruent to angle TC by CP, CTC. Well, we just show by proving that these triangles are congruent, we know their parts are congruent, these angles, and those angles that we just stated are congruent happen to be alternate interior. Okay? So we just showed that alternate interior angles are congruent, so we can say that those lines are parallel. Okay? We can state that AB is parallel to CD. We can say that BC is parallel to AD. What's our reason when we prove the angles and show the lines are parallel? Does anyone remember? Not a long time ago. It wouldn't be alternate interior angles are congruent. There's a special word we have to put in front of that because we went backwards. Converse. Good. So we're going to state that those lines are parallel. So we're going to say AB is parallel to CC and BC is parallel to AB by the converse of the alternate interior angles theorem. You just say converse of alternate interior angles theorem. Well, we just showed that the opposite sides from this quadrilateral are parallel, so can we now say that this is a parallelogram? Yeah. So you're just going to state for 7, you're just going to state what you're trying to prove. Quadrilateral ABCD is a parallelogram. ABCD is, and you can just abbreviate with the symbol, or write the abbreviation for parallelogram. And your reason is just, you can either say opposite sides of a quadrilateral that are opposite sides of a parallelogram are parallel, or just say definition of parallelogram. And that's fine. You can state the definition of it or say definition of parallelogram. Good. Okay. So when you have to prove that something is a parallelogram, you can't start out with saying, well, these lines are parallel, we're going to use alternate interior angles. Okay? You have to use other information that you give you. Prove those triangles are congruent, state their parts are congruent, and then state that they're parallel by alternate interior angles. Okay? Questions over that? Okay. The rest of the time is yours.